Lists. The next data structure we will learn about is the list type. A list is a sequence of values, all of the same type. For instance, you could have a list of numbers, or a list of strings. You can even have a generic empty list. A list is a type, much the same way that int, for integer, is a type. However, the list will also usually have an element type, which is what the list is composed of. So if you have a list of integers, its type is list and its element type is integer. We create lists using square brackets on their own. Each value that we want to put into the list is separated by commas. The square brackets are critical to making this a list, without them it is not a list. We've seen square brackets used before, when we were subscripting and indexing a string. Confusingly, Python also uses square brackets for creating lists. You might struggle at first figuring out when you're looking at subscripting or list creation. The key is whether the square brackets come after an expression, that means subscripting. If the square brackets are on their own, you have a list. A pair of square brackets with nothing between them creates an empty list. An empty list is like an empty bag. You may not have anything in it, but you still have the bag itself. Empty lists do not have an element type until you put something in them. When used as a conditional, a list evaluates to true unless it is empty according to the rules of truthiness. This can be very convenient when writing conditional expressions involving lists. If you want to test if the list is not empty, you just write the name of the variable holding the list. When you print a list, you will notice that the square brackets are printed too. In fact, Python print each value of the list as if it was a literal value. So notice that the strings have quotes around them now. Lists are often shown in diagrams as a row of boxes, to help us visualize the data. Each box will have a value in it. The boxes may also have numbers below them, showing the indices of the values starting from 0. This is similar to how indexing strings works. When you define a function, you need to specify the types of the parameters and the return value. If you don't know the element type of the list, you can just use the list type like we would a string or an integer. The left function consumes a list and produces an integer. But if we do know the element type, we add the element type, wrapped in square brackets, after the word list. These example functions here demonstrate how this looks visually. We do not know how to implement them yet, but they can at least show us how to write the types. Some people will use the words array or vector to describe lists. These are actually slightly different concepts, which we will not cover in this course. Don't be thrown off if someone refers to a list as an array, but don't use that word yourself.